Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This lesson is for Course 2, Lesson 4-8, Solving Inequalities by Adding or Subtracting. The title is our objectives as well. So let's learn about the addition property of inequality and the subtraction property of inequality. They're very similar to the addition and subtraction properties of equality. So very much the same idea that we used in solving equations we'll be using here to solve inequalities as well. So you can add the same value to each side of an inequality. So what that tells us, since 7 is greater than 3, 7 plus 4, 4 is just a random number, is greater than 3 plus 4. Okay? Or since 1 is less than 3, 1 plus 4, again, random number, is less than 3 plus 4. If you work out the math, 7 plus 4 is 11, 3 plus 4 is 7, so the greater than remains true. 4 plus 1 is 5, 3 plus 4 is 7, 5 is less than 7. It remains true. Algebraically, if A is greater than B, then A plus C is greater than B plus C. Or if A is less than B, then A plus C is less than B plus C. So adding the same value to each side of an inequality maintains the truth of the inequality. Similarly, the subtraction property of inequality tells us that we can subtract the same value from each side of an inequality. So let's look at it with numbers. 9 is greater than 6, so 9 minus 3 is going to be greater than 6 minus 3. Quick check here, 9 minus 3 is 6, 6 minus 3 is 3. It's true, 6 is greater than 3. Okay. Similarly, 15 is less than 20, so 15 minus 4 is going to be less than 20 minus 4. 15 minus 4 is 11. 20 minus 4 is 16, so 11 is less than 16. True statement. Okay. Algebraically, if A is greater than B, then A minus C is greater than B minus C, again C being any number. If A is less than B, then A minus C is less than B minus C. Okay, so subtracting the same value from each side of an inequality maintains the truth of the inequality. Okay, so now let's go ahead and look at some examples. Solving inequalities by adding. Solve q minus 2 is greater than or equal to negative 6 and graph the solution. Okay, so again, here we want to isolate the variable, so we think what's the opposite of subtracting 2? Pardon me, subtracting 2, and that would be adding 2. So I'm going to add 2 to each side of the inequality and simplify. Q minus 2 plus 2 gives me Q is greater than or equal to negative 6 plus 2. Negative 6 plus 2, remember, since signs are opposite, you subtract absolute values. 6 minus 2 is 4. Then you give that answer a negative sign because negative 6 has the greater absolute value of these two numbers. So it tells you that Q is greater than or equal to negative 4. So all numbers equal to negative 4 and greater than negative 4 or greater than negative 4 make this true. So I'm going to put a solid dot because of the equal sign here at negative 4, and I am going to shade to the right because I want numbers that are larger than negative 4. Any one of these numbers in the shaded area would give me a true statement. So for example, if I tried to substitute 0 into the original inequality, 0 minus 2 is negative 2. Negative 2 is greater than negative 6. That's true. So you can check your solution by substituting in, similar to what we did with equations. Okay, so here is a quick check number 1. Use algebra. Graph your solution when you're finished. You can wait and do it at the end of this lesson or pause and do it now. I'm going to continue moving through the notes. And number 2 is solving inequalities by subtracting. So we have d plus 9 is less than 8. And then we want to graph the solution as well. So again, I want to isolate the variable, so I'm going to subtract 9 from each side. So d plus 9 minus 9 is less than 8 minus 9. So d is less than negative 1. Okay, so here's negative 1 on my graph. I'm going to have the open circle because I do not want to include negative 1 as part of my solution. I'm going to graph to the left, or shade the number line to the left, because those numbers would make the inequality true. Notice that if you put negative 1 into the inequality, negative 1 plus 9 is 8. 8 is less than 8. Makes it false. So that also gives you the clue that that needs to be the open circle in there. So I'll just jot a little note here. You may find that useful to jot it down for yourself. It's up to you. Okay. The drama club can spend no more than $120 for costumes. They already spent $79. How much more can they spend for costumes? So we want to write an algebraic sentence, in this case an inequality, and let's see what we come up with. So we know we have the amount already spent plus amount to spend on costumes is at most $120. Okay, so what we want to do is, and this should actually amount that to be spent. Well, that's not the right in there. I don't think that's a good. The amount already spent, the amount left to be spent probably is what it should say. I don't think that says that very well. Okay, so let's say that 79, the amount of money that they already spent, plus what they still have left to spend, is at most $120. So less than or equal to, because it can reach $120, but it can't go over, and it doesn't have to quite reach it as well. All right, so here we go. We want to subtract 79 from each side so that we can isolate the variable of c. Okay, when I subtract 120 minus 79, that gives me 41. So c is less than or equal to 41. That means they can spend at most $41, no more than that, but up to $41. Okay. All right, couple of more. 2 more quick checks. One's multi-part. Have the 3 quick checks ready when you come to class next time. Also, please be sure to bring in any questions you might have. I look forward to seeing you soon. Bye.